All right, the last set of examples for this chapter on right triangles is actually really just a summary of all of our trig skills and Pythagorean theorem. So kind of putting them all together potentially in one problem. So what we want to be able to do, or what the directions are going to tell us to do for these problems, is to solve a right triangle. What that means is to find all of the side lengths and all angle measures for a right triangle. So there's 3 side lengths and 3 angle measures. When we're doing this, we will either start with knowing 2 side lengths, 1 side length and 1 of the acute angles, 1 side length and 1 trig ratio. Keep in mind that we always know one of the angle measures is 90 degrees because it's a right triangle. To find the missing sides and angles, we're going to use a combination of the Pythagorean theorem, trig ratio equations, and then inverse trig ratio equations. So our first example here, we have 2 sides. So if we're keeping track of what we know, there are 3 angle measures and then 3 side lengths. At this point, we know AC is 6, CB is 8, and we know that the measure of angle C is 90 degrees. So 2 angles and 1 side to find. The first thing that we'll do is find the side length of AB, and we're going to use Pythagorean theorem for that. So 6 squared plus 8 squared equals, we'll just call it x squared. That's what we're looking for inside AB. This is actually a Pythagorean triple, so a little bit of a shortcut. I know that x is going to be equal to 10. X was AB, so we'll put in a 10 here. Second thing we're going to do is either find measure of angle A or B. It doesn't matter what order we do it in. I'm going to go with A just because we'll go alphabetically. So if we are looking at angle A, it's the label of the triangle with respect to angle A. This is the opposite side, the adjacent, and the hypotenuse. As much as possible, you want to use values that were given to you in the problem versus ones that you found. So like we found the 10, but we were given the 8 and the 6. So I'm going to use the 8 and 6. With respect to the angle A, 8 is the opposite, 6 is the adjacent. That trig ratio is tangent. So the tangent of angle A is equal to 8 over 6. Looking for an angle, know the ratio means we need to use inverse. So the inverse tangent of 8 over 6 is equal to the measure of angle A. Using the calculator, 53.13. We're going to round to the nearest hundredth. And the last part, we could use the fact that we have angle B here and do another inverse ratio, but something that we should add up here is that the sum of the angles in a triangle equals 180, and also the sum of the acute angles in a right triangle equals 90. So I'm going to use that fact to say that the measure of angle B is going to be 90, take away the measure of angle A we just calculated, 53.13. That's 36.87. So that's what it means to solve a right triangle, to be able to find all of the missing sides and angles. This is the procedure that you would use, or the steps you can follow if you are given 2 sides. For this second one, we are given 1 side and 1 angle. We're going to do the same thing where kind of make a place to keep what we know organized. We know that CB is equal to 4, measure of angle C is 90 degrees, and we are given the measure of angle A, 31 degrees. So we have one angle and two sides left to find. For this one, we're actually going to start kind of with the strategy we used last in the first example, with the fact that the acute angles add up to 90 degrees. So the measure of angle B is equal to 90. Take away that measure of angle A, 31. So that's 59 degrees. Can certainly label things as you know them in the triangle. Then we have two sides to find. We're going to use trig ratios, not the inverse ones, the original ones, when we know an angle and we want to find a missing side. I'm going to label the triangle with respect to the angle A, the one that was given to me, not the one I calculated, just in case I made a mistake with the one I calculated. So this is the opposite, adjacent, and hypotenuse. If we want to find AC first, AC is the adjacent side, so we want the adjacent side. We know the opposite. That means use tangent, TOA, the opposite over adjacent. So the tangent of 31 is equal to 4 over, we'll call this x, the length of AC, the adjacent side, cross multiply. Divide. And we'll have 6.66 if we round to the nearest hundredth. The last thing we have to do is find AB. We could use Pythagorean theorem, but we would be using a rounded value of the side length of AC. So rather than do that, I'm just going to go back to using a trig ratio again. So AB is the hypotenuse. So we want to know the hypotenuse. We already do know the opposite side. So opposite and hypotenuse go with sine. So the sine of 31 is equal to the opposite over the hypotenuse. I'm going to call it y. We'll solve this equation. We get 7.77. Again, it should work out that the biggest side is opposite the biggest angle, which it does. 7.77 is opposite the 90. That's the biggest side. The smallest side of 4 is opposite the smallest angle of 31. And then the medium side of 6.66 is opposite the medium angle of 59.